In this video, we're going to look at comparing and ordering real numbers. So keep in mind your real numbers are all numbers that are either rational or irrational. And the first example we're going to look at, we're going to take three numbers. So the first one is pi squared. The second one is 10. And the last one is the square root of 75. And we're going to work to put these numbers in order from smallest to biggest. And when you're given a problem like this, your first goal is to make all the numbers something that's easy to compare. So I'm going to try to make each of these into a decimal. So I know that in order to find pi squared, I'm going to use the rounded version of pi, which is 3.14, and multiply it by itself. And that's going to give me a decimal answer of 9.8596. The 10 is nice because it's a 10, so I don't have to do anything with it. The square root of 75, I know that 75 is not a perfect square, so I'm going to have to estimate what that square root is going to be. So I'm first going to give myself a number line here and start by figuring out, based on my perfect squares, about where that square root of 75 would sit. So I know that 81 is a perfect square, and that would be a little larger than 75. And I know that 64 is a perfect square, and that would be a little bit smaller than 75. If I actually calculate the square root of 64, it would be 8. And if I calculate the square root of 81, it would be 9. And I'm going to break this number line in half to kind of make it a little easier to work with. And I know the midpoint between 8 and 9 is 8.5. So I want to determine first which side of the number line would square root of 75 sit on. So I know that the square root of 75 is 11 away from 64, but between 75 and 81 is only 6 away. So I feel comfortable saying that the square root of 75 should sit somewhere on the right-hand side here. And now it really comes down to guessing and checking. I know in between 8.5 and 9 I have 8.6. Oops, sorry about that. I have 8.6, 8.7, 8.8, and 8.9. So I'm going to start off, I'm going to try squaring 8.7. And if I multiply 8.7 times 8.7, I get the decimal 75.69. So I'm pretty close to my goal of 75. I'm actually a little bit larger than it. So I'm going to go 1/10 smaller and figure out what 8.6 squared is. And 8.6 times 8.6 gives me 73 and 36/100. So looking at my two options here, the 75.69 is the closer to 75. So I'm going to estimate that the square root of 75 is 8.7. So let me get a pen over here. So we know now that the pi squared is 9.8596, and we know that the square root of 75 is approximately 8.7. So now I'm really comparing 8.7, 10, and 9.8596. So going from smallest to biggest, the first number, the smallest number, would be the 8.7. So I'd say the square root of 75 is the smallest. Working our way up, we would then go to the 9.8596. So pi squared would be the second. And then finally, our largest number there would be 10. And that's an example of how we would order real numbers. I can also compare real numbers. So I can have two expressions such as 12 minus the square root of 2 and a second expression of the square root of 9 plus 3. And I can compare which one is bigger and which one is smaller in a very similar manner. Before I can actually solve this expression on the left, I need to figure out what the square root of 2 is. And since it's not a perfect square, I would estimate it in a similar manner to what I did before. And my estimation would tell me that the square root of 2 is approximately 1.4. So this expression can become 12 minus 1.4. And if I actually find the difference there, I get an answer of 10.6. In my second problem, the square root of 9 is a perfect square. I know that to be 3. So I just solve 3 plus 3, and that gives me 6. 10.6 is greater than 6, so I would use my greater than symbol.